Shakti Devi. Shakti Devi. Proceed, ma.
Good afternoon to everyone. This is P. Shakti Devi of 3rd B.Sc Mathematics from Mahalashmi Women's College of Arts and Science. We are delighted to have you all in this webinar session, which is organized by the PG Department of Mathematics. Prayer is always be our first response to every situation, as there is nothing greater than God, who is merciful. Let us start our session with a prayer song with the blessings of Almighty.
ஐந்து கரத்தனை ஆனை முகத்தனை இந்தில் இளம் பிறை பாலும் ஏற்றனை நந்தி மகந்தனை ஞான கொழுந்தினை புந்தியில் வைத்து அடி போற்றுகின்றேனே.
நமஸ்தேஸ்து மகாமாயே ஸ்ரீபீఠே சுரபூஜிதே சங்கசக்ர கதாஹஸ்தே மகாலக்ஷ்மி நமோஸ்துதே. நமஸ்தே गरुडारूढे कोलासुरभयङ्करी सर्वपापहरे देवी महालक्ष्मी नमोस्तुते. सर्वज्ञे सर्ववरदे सर्वदुष्टभयङ्करी सर्वदुःखहरे देवी महालक्ष्मी नमोस्तुते. सिद्धिबुद्धिप्रदे देवी मुक्तिमुक्तिप्रदायिनी मन्त्रमूर्ते सदा देवी महालक्ष्मी नमोस्तुते.
Now, I would like to call upon our Puja of 2nd B.Sc Mathematics to deliver welcome address.
A very good afternoon to one and all present here. This is our puja of 2nd BSc Mathematics from Mahalashmi Women's College of Arts and Science. I welcome you all this the 46th day of MAHA webinar marathon on behalf of Mahalashmi Women's College of Arts and Science. I extend my sincere thanks to our principal, Dr. R. Kumudani ma'am, and our vice principal, Dr. S. Ramasamy sir, and Dr. U. Indumati ma'am, who stands as a great support to our achievements. I extend my hearty welcome to our chief guest, Dr.A.FELIX sir, Assistant Professor, Department of Mathematics. Welcome, sir. I welcome all the HODs and faculties from the various departments. I like to welcome all my dear friends and participants who are all gathered here. Once again, I welcome you all.
Thank you, Pooja. Now I call upon S. Reshma of 2nd M.Sc Mathematics to welcome the guest speaker.
Good afternoon, everyone. Stars shine at night. Some stars shine at bright daylight. It's our pleasure to welcome such a star, our Honorable Chief Guest, Dr.A.FELIX Sir, Assistant Professor, Department of Mathematics, School of Advanced Science, Vellore Institute of Technology. He completed his doctorate in Loyola College, Chennai. He was having more than 10 years of teaching experience. His area of research and fuzzy model and its application. He received awards like Outstanding Scientist Award given by VD Good Technology, Young Researcher Award in Fuzzy Model, Maulana Kalam Azad National Fellowship Award by UGC for doing a PhD research program, Sambhu Varyar Endowment Fellowship for the outstanding percentage of marks in M.Phil by University of Madras, and so on. He was currently guiding 6 PhD scholars. He published more than 50 articles. He has given invited talks in 29 institutions. He published 3 books and 2 edited journals. He
Thank you. It's a time for photograph. I request everyone to switch on their video for memorable photograph of today's session. Thank you all. Now I hand over the session to our guest speaker, Dr.A.FELIX sir. The session is yours, sir.
Thank you, my dear students. Is it fine? Is my screen visible? Can I get your response?
Yes, sir.
Okay, thank you. Thank you. So at the outset, I would really thank the management of Mahalashmi Women's College of Arts and Science uh, the chairman through S. Kunjidapadam, the managing director through S.K. Thirukumaran, the principal of this college, Dr. R. Kumudini, and Vice Principal Dr. S. Ramaswamy, Vice Principal Academics Dr. U. Indumadi, and all the faculties of Department of the Mathematics, head of the department, and for providing this wonderful opportunity to interact with the students' fraternities. It is always joy to meet the students and to share our knowledge and to get the knowledge from the students. I always believe students is the wonderful source of learning things. So you can see that a lot of innovative ideas are there from our students. Okay, the fresh mind, young mind should be utilized properly. That we could witness in today's webinar. And if we look at the today's webinar, the most of the things are being organized by the students. But behind the students, all of the faculty members are there. That the good teacher would be like this. The good teacher will always bring the students to in the limelight. So that's what we always believe. The teachers are like a ladder. They will make all the students to go up and to see the world. So what we have seen already, that we will make our own students and this generation to see the world, how the world is beautiful. So that you can see that through only the education. Education only dispel the darkness to bring the light in all of us. Okay. So that I could witness from the Mahalashmi College students. I'm happy that all the students will come forward and organize the things. That is the good sign. Okay. So in the college, not only you learn the academics, how the things or how the events can be organized. All such things you can learn. And of course, all your teachers are training all of you. That's good. And at the outset, I also like to thank my friend, Professor Krishna Kumari, for inviting me for this webinar. Thank you. So with this, let me start my presentation. So today's talk is on Cipher and RSA Crypto System. Okay, this is very, very interesting. Okay, so whenever we want to send a message to any of our friends, we feel that should be sent secretly without broken by the third party. Okay, without stealing by the third person. How the message can be sent secretly. Now you are sending the message, okay, to your friend. How this particular network or something will send it to the person without breaking it by the third person. Okay, so the entire world is keeping the things secret. Okay. The same way, those days when the king was reigning the entire nation, how the king would send a message to secretly. Those days the war would be going more than a year. Okay, so it goes year and year, month and months. Suppose the king wants to send the message to the marshal, the captain of the soldier. How you would send the message? Those days, what they will do? They will find some reliable person. Okay, reliable person. The reliable person head would be shaved, and they will write the message on his head. Okay, the reliable person, the reliable soldier, has to wait till hair comes back to the original form. Then you would be sent to the place where the war is going on. So where the marshal, the captain of the soldier, would shave his head and read what the information is given by the king, and he will go ahead what is instructed. Okay, suppose the person caught by the opposite kingdom. Okay, what will happen? So usually they may not thinking that something is written on his head, isn't it? They will leave it. Suppose if they found that something is written on his head, then the message would be stolen. Okay, still the information is not secret. So what they have done slowly, why can't we bring some mathematical ideas and mathematical logic behind this crypto? Okay, to send the message secretly. Okay, so a lot of things are going on, but today we will be learning Cipher. Okay, the Cipher, which will be dealt by the linear algebra. Okay, system of linear equations. using the linear algebra concepts, how one can make system to send the message secretly. Okay, this 1929, Lester S. Hill, okay, the mathematician called Lester S. Hill, who brought this cipher concepts in 1929. Okay, this is done in the year 1929. Okay, later, and three mathematicians, Ron Risvest, Adil Shamir, and Leonard Adeline. These three mathematicians and computer scientists join together and bring this crypto system. Therefore, the system is kept in their first name. Okay, Ron, Adil, and Adelman. So their first letter is kept, RSA Crypto System. This was introduced in 1977. After some 50 years, they brought this RSA Crypto System. This RSA Crypto System is designed on the basis of the number theory. Okay, so whereas this cipher system is done by the linear algebra. Okay, so today we shall learn this linear algebra and number theory, how important, how it is being utilized in our day-to-day life. Okay, that we shall see that. So the talk is on cipher and RSA Crypto System. Okay, fine. So whenever I talk something about linear algebra, or I always feel that. So though we study linear algebra, solving the system of linear equation, the the B is not in the column space, we cannot solve, the solution is not there. When the solution is not there, we can partially give the solution. That is a least square approximation. All such things you will be learning in linear algebra. I feel that even our grandparents who are illiterate, okay, we are utilizing this linear algebra. Even without knowing linear algebra concepts in our day-to-day life, we are utilizing this linear algebra. Okay, I'll tell the thing that has happened for me when I was doing some 7th or 8th standard at my village. One of my grandparents from my village, who was illiterate, even he didn't go to the school. Okay, so he posed a puzzle. He was doing some carpentry work. I was watching him, and he posed a puzzle to me. Usually, whenever the relatives comes to our home, they will post some puzzle. They will check how our mathematical knowledge will be, isn't it? They will ask us to solve the problem. They will post some puzzle to us. They'll make us to solve the problem. Those days, nowadays, the trend has been changed. When the relatives comes to our home, they will ask whether you have a charger, the bigger one or smaller one charger do you have or not. This is how the relationship would be there nowadays. But those days, our grandparents would talk to us, okay, so that our relationship will be built up, and then they are making us, they will also guide us to go in a right way. But now the situations are different, because mobile phones has come into the picture and it becomes the part of our body. Now we forgot everything, isn't it? Okay, fine. So let me come back. My grandparent, one of the grandparents from my village, who posted this puzzle. This is the puzzle. Okay, let me post this puzzle here. Okay. Frankly speaking, at the time, even I was not able to answer for this puzzle. What he said, he said this, I'll give 100 rupees to you. I need 100 goats. Okay, you might have probably heard this puzzle from somebody. Even I used to tell this whenever I start, solving the system of linear equation. Okay, he said this, I'll give 100 rupees to you. You need to buy 100 goats exactly for 100 rupees. But in the market, the male goat is 10 rupees, female goat is 5 rupees, baby goat is 50 paise. Okay. Then how many male, female, and baby goat you would buy to get the 100 goat exactly for the 100 rupees? Okay, 100 rupees he has given to me. He asked me to buy 100 goat exactly with a combination of male, female, and baby goat. Then how many I would buy? This is the question he has posted. I was not able to answer for it. And after I was doing something and then I was calculating, I was not able to answer for it. And after half an hour, he gave me the answer for it. Okay, so anyone has the answer for it? If you have an answer, no issue. Okay, you just keep it. Okay, so he gave me the answer is 1 male goat, okay, 9 female goat, and 90 baby goat. 1, 9, 90. This is the thing he has given to. So which means that 1 tens are 10, 9 5s are 45, and then 90 baby code, 90 into 50 paise is 45. You can see this. This is 100 rupees for 100 goats. This is the question he has given to me. Later, after I was coming to the college, my teacher was taking the linear algebra, the system of solving the system of linear equation. At the time, I was thinking, whether is it related to the system of linear equation? I was thinking, and then I just framed this equation. Okay, so let me take this male female baby goat as XYZ. Okay, so what are the two conditions he has given? What is it? When you buy, all the 3 goats should be 100 in numbers. X plus Y plus Z is equal to 100. So the first thing is the number of goats, isn't it? This is the number of goats. And second one would be, what is that? The cost. Cost should be 100 rupees. Okay, what is that? Male goat is 10 rupees, 10x. Female is 5 rupees, 5y. And this is 50z, 5z. Okay, so here we obtain, what is it? 3 equations, and then 2 equations and 3 variables. Okay, 3 variables are there. If you put it this in terms of the system, this is, we have the 2 equation, 3 variables, isn't it? So we know the system of equation, and yes, a linear equation, set of all linear equations with the same unknowns, x, y, z, or the unknowns. So if you put it, A is the coefficient matrix. What is it? 1, 1, 1, 10, 5, 0.5, and x would be x, y, z. Okay, this is the unknown variable, x, y, z, and b would be 100. Okay, so this is the system of linear equation. Ax is equal to b. We know this. Ax is equal to b. Okay, solving the system, we can have either unique solution, no solution, and infinitely many solutions are possible. Okay, infinitely many solutions. But here we have 2 equation, 3 variable. Okay, when the variables are greater than the number of equation, then you can have infinitely many solutions. And then if you want to see whether the system is unique or not, if the determinant of this matrix should be non-singular. Okay, determinant should be the non-singular, then you can have unique solution. For no and infinitely, the determinant would be 0, and all after this some sort of condition it will hold, and then you can check whether it has no solution, infinitely many solution, that you have learned at your linear algebra class. Okay, fine. This is what the grandparents who were illiterate, who didn't go to the school, and look at this. He was using the system of linear equation. I was wondering, without knowing the mathematics, he was utilizing all the mathematical concepts. Okay, what we think, though we study mathematics, we may feel that we are the richest person in the mathematics. Not like this. The person who didn't know, who didn't aware of the mathematics, he was utilizing. If you look at the departmental store person, so he spends every day, he buys some things, and then what is the profit and loss, that can be done it through the system of linear equations. Without knowing the system of linear equation, we are using in our day-to-day life. Okay, fine. So linear algebra is a study of vectors and the linear transmission. So linear algebra is concerning solving the system of linear equation. Okay, now what we are going to view here in Cypher. So in Cypher is done through this Ax is equal to b. Okay, so that's why I've just given an introduction about this system of linear equations. Okay, fine. Okay, so linear transformation and all, the matrix is itself is viewed as a linear transformation. Look at this. If you transform this vector, x is the vector, transform this vector through this matrix, you will be getting your b. Okay, so suppose this x you can obtain. There are solving this system you would have done in the lower classes by the Cramer's rule, substitution method, graphical method, elimination method, by the inversion method. So many methods that you are used for finding the solution of the system. So pre-multiply by A inverse on both sides, then you can have A inverse is equal to B. So if you transform this B through this A inverse, you will be getting this X. Okay, so we will be using this in the cryptography. Okay, that crypto system is in Cypher. Okay, so crypto is the sending a message, the study of encoding and decoding secret message is called encrypto. It is the cryptography. Suppose. So look at this. Whatever the message that we have, okay, that message is the plain text. Suppose this is the message just I want to convey to all of you. Okay, leave. This is the message. Okay, this is the plain text, right? This is the plain text. This is the plain text. Okay, so what we have to do, this plain text is converted into the coded one. Code. Okay, code. Okay, the coded one would be called as ciphertext. Okay, ciphertext. So in lower classes, I mean, when you were school students, you would have played this kind of game. So, you know, A, B, C, D, all the alphabets are assigned the numbers A, B, C, D. So A is assigned 0 or 1, B is 2, C is 3, D is 4, and 26 is kept as 0 because here, I mean, Z would be 0. And then Y is kept as 25. Okay, so 26 is divided by 26, it leaves a remainder. Therefore, we have kept 0. That is the integer modulo n that we will be seeing here. Okay, so by using this, what is that? L plus 3, something you have taken. Okay, whatever the plain text you have, you are added some number p plus 3, so that whatever you are getting p plus 3, this is the ciphertext. The conversion from plain text to the ciphertext is the encryption. Okay, Encipher. The conversion from the plain text to the ciphertext is the Encipher. From ciphertext to the coming back to the plain text is the decipher. Okay, so the numbered cryptography is the study of encoding, decoding a secret message is called cryptography. Okay, here what you're going to do, the plain text will be converted into the ciphertext. This is the Encipher, and ciphering into the plain text is the deciphering. Okay, fine. And then the first I told you that how the king, those days the king were sending the message when the war was going on. I told it, and that was also not secret. If the person is not reliable, then what will happen? Immediately the message would be stolen. Okay, and then later they have used something. They will have this kind of ruler. Look at this. They will have some ruler. You know, they will have something, you know, paper or the cloth to write the message. If you rotate the paper or the cloth on one side, then in the one side they will write it some message. Suppose leave the message, leave. This is the message they want to write it one side. And then if you take it out from the ruler, then somewhere you can have the emptiness, isn't it? L, E, A, B, you can have. In between you can fill it some word P, L, M, X, Y, Z. Okay. The person who received the message will also have the same ruler. This is called title. They will rotate, and one side they could see the message. Okay, so this is also one way of sending the message. Okay, still it is not secret, right? Therefore, they thought that some mathematical concepts can be utilized here. So look at this. The plain text A, B, C, D, F, G, Z would be the plain text. Now what we have done, the plain text plus 3 is taken. Okay, plus 3. If you do that, this is what will happen. A would be P, A plus 3. D, similarly, we have done. Suppose I want to send this message, Mahalashmi. Mahalashmi. So look at the M. M is the M plus 3. NOP. Okay. Similarly, A, B, C, D. Okay. So this is the message. The ciphertext would be received by the suppose I want to send this message. The person who will receive this ciphertext. Okay. Now the person want to read the message. How she or he can read this message. Okay. So what is the inverse of 3 is under addition is -3, isn't it? So what is that? C is equal to P plus 3. This is the plain text, and then bring this term to this side. C minus 3 is equal to P. This is F of C. Okay, F of C. So what will happen? This ciphertext minus 3. P minus 3. 1, 2, 3. M. Okay. D minus 3. A. Mahalashmi. You can get it. So this is the Encipher. This is the deciphering. Okay, deciphering. Still, look at this here. How many? 1, 2, 3 A's are there. By looking at itself, they would identify that. Okay, so which means that something they are using plus 3, because here only one partition that you have taken. Okay, so from this you can easily identify the pattern. and the message can be stolen easily. Still, this is not secret. So how the message can be sent it secretly? Okay. So this is what I told you. Suppose the king wants to send this message something to the soldier. So they will find some reliable person, something attack the message is the king wants to give to the marshal. This is a reliable person. His head would be shaved. This message would be written on his head, and he would be sent where the war is going on. Okay, and then the marshal would read the message, and they can go ahead. Okay. Suppose if he's caught by some opposite kingdom, then this is stolen easily. Okay. Okay, fine. So this is I told you. Okay, fine. But here we are utilizing the arithmetic concept, modular arithmetic concepts. Okay. So we know this, the modular arithmetic, A congruent, B mod 26. Okay, mod, because here we are using the 26 alphabets, we are utilizing this. Okay. So this is the integer modulo 26. Here we would be using integer modulo 26, which means that all the possible, what are the possible reminders? You can have 0 class, 1 class, till 25 classes would be there. Okay, 25. Okay. Okay. So in the arithmetic modulo, you can have additive modulo and multiplicative modulo and the congruence modulo. So all the things that you have learned in your classes. If not, you can have a glimpse after this class. But anyway, what are the things it is required that I would tell you. So A congruent me, B mod n, this is if and only if M, this, let me put it instead of this 26, let me put it M. Okay. M divides A minus. Okay. If A congruent B mod M, then M divides A minus B. If M divides A minus B, then A congruent B mod M, if and only if. Okay, fine. So let us take when 7 is divided by 5, what is the remainder it leaves? 2 is the remainder it leaves. If and only if 5 divides 7 minus 2. Okay, fine. Similarly, when 19 is divided by 4, what is the remainder it leaves? 16, 8. What is that? It leaves a remainder 3. It leaves a remainder, yeah, 4 4s are, yeah, 16. 3. Yes, good. Similarly, 12 is divided by 3. What is the remainder it leaves? 0, right? 4 3s are. So this is the congruence modulo M. Okay, modulo M in the sense. So the set of all classes, this leaves a remainder. For 26, when the integer is divided by 26, it leaves these possible reminders you can. So 0 classes you can have, isn't it? 26, 52, all the things will come. From the minus side is minus 26, minus 52 goes. Similarly for 1, 0, 27, when 27 is divided by 26, it leaves a remainder 1. So all such classes you would be getting. Fine. Okay, because here you are going to, when the numbers are multiplied with the matrix, you will be getting more than 26. And how would you identify, because here only 26 alphabets are there, and how are you going to bring it for that particular term? So when the number are restricted with the mod 26, you will be getting within that you can bring it. Okay, fine. Okay, so initially, what we have done, the plain text is changed into the ciphertext by using the P+3. So where only one partition is there. With this, you can easily break it. But here, what we have done, we are going to do, what is that? It is going to be divided into so many sub partitions, and then the message is going to be shared. Okay, that is called poly cipher. Okay, here you're going to divide into into so many subregions and then sending the message. Okay, so in the simplest in cipher, the successive pairs of plain text are transformed into the ciphertext. So what is it? You're going to here, suppose this is the message I have. What is it? Leave this message I want to convey. What we are going to do, you're going to divide into the pair of elements. Either you can make it pair of elements or make it into the 3 elements. Okay. So if you make a pair of elements in the here, you get a 1 term left. So the letters length is the or therefore you are given a privilege to add some dummy variable. Okay, the thing is you make it into the pair of elements. Also, you can also make it into 3 elements or also. Okay, you can make the group with the 3 elements, or grouping with the 2 elements is also possible. Okay, n number of elements that you can make it. This is called the poly cipher. Okay, and then everyone is having the phone number. Okay, even everyone has the intercom. So my intercom is 1592. Consider 1592. This is my intercom. I make this as my matrix. A is equal to 1592. This is, suppose anybody wants to send the message to me, what they can do, they can take my number 1592. Through this, you can transfer and send it to me. Okay. Suppose leave L position, I know this, E position, I know this. Okay, that you can transfer this, whatever you obtain under mod 26, the remainder would give the corresponding letter, and that you can send it to me. Okay, fine. The first thing is what you have to do, choose 2 by 2 matrices or 3 by 3, anything. Okay, so here we have chosen 2 by 2 matrix. This is the 2 by 2 matrix. Okay, and then whatever the message that we want to make it, I just want to make it into pair of elements because I have a 2 by 2 matrices. The multiplication is possible only if it is, what is it, 2 by 1. Okay, so therefore what we are going to make, you are going to make a pair of elements. If it is 3, you are going to group them into 3 elements. Okay, fine. If it is odd number, then you are privileged to add some dummy index. Fine. And third step, the plain text whose corresponding the numeral value will be taken, and then it is transformed through this AX is equal to B. Here AX is the plain text, B is the ciphertext. Okay, ciphertext. The matrix, this is the matrix, my matrix is there. Okay, so here somebody is taking my matrix. It is, I'll show this publicly, I'll show this matrix. Okay, so this will be the plain text, because here you will be taking 2 by 2, because this size is 2 by 2, this is 2 by 1. Okay, transforming this under mod 26, whatever the remainder leaves, that is the ciphertext. To get back the original one, the plain text would be A is equal to X is equal to A inverse of B. I can know my inverse of the matrix. Okay, through which I can find it out my X. Okay, this is the IL cipher. Fine. Let's see this, how the message can be sent secretly. Okay, so the plain text is love. I want to send this message. Okay, so we want to express, so we are here to love each other. Okay, this is what all the religion says, love your neighbor as yourself. Therefore, just I want to convey this message, love. Okay, so suppose someone wants to send this message to me. This is my phone number or intercom, anything, 2315 The L position is, what is that? The L position 11 and O position is 14. So here it is going to be divided into pair of elements. It's 11, 14. When you multiply them, you are getting 262, 263 under mod 26. When it is divided by 26, what is the remainder it leaves? 2, 3. Okay. The 2 position is, what is it? C. This is C. And then 3 position is D. CD. Okay. Similarly, another set of letter V you can take, transform the corresponding term is 21. Each position is 4. Transform through this matrix, and the resultant would be divided by 26. Okay, the remainder is R 16 and 5. 16 is Q and 5 would be F. Okay, so CD, Q, F. This is the message would be sent. Now I want to read this message. How can I do this? I can do this by A inverse. Okay, A inverse X is equal to A inverse of B. Okay, through the A inverse. Now look at this. X is equal to A inverse of B. Okay. Now the question comes. We know this. Suppose A is a 2 by 2 matrices, A, B, C, D. How do you find out the A inverse for this? 1 by determinant of A, and then what is that? D, A minus B minus C, isn't it? Suppose the determinant is 1, no issue. 1 is the inverse for 1 itself. Suppose some term is there. How are you going to find it out, the inverse for it? Okay, if you know the inverse of this, then you can proceed in finding the inverse of the matrix. Okay, or read the message. So look at this. Suppose, for example, I want to find it out, the inverse of 3. Okay, I want to find it out the multiplicative inverse. You know the multiplicative inverse, right? Under mod 26. Suppose I've taken a belongs to integer modulo m. You have taken a is from integer modulo n. Of course, this a inverse will also be there at integer modulo m. Okay, then the a inverse is the multiplicative inverse of a. Then a is into a inverse. This is equal to a inverse into a would give the identity. So one is the multiplicative identity mod, yeah, isn't it? This is what. Suppose I want to find it out the inverse for 3. Okay. So what would be the inverse of 3 under mod 26? Okay. So how are you going to do that? So let us do this. So we know this. Let us take 3 inverse is x. So we know this 3 into 3 inverse would be 1 mod 26. This is under mod 26. Okay. So let us assume 3 inverse is x. 3x is equal to 1 mod 26. And then, so 3x bring this 1, this is minus 1. This is equal to 26k. Because the resultant would be the multiplicative of 26. Okay. So then what would be the k so that this would be divided? 26k minus 1. So what k you can bring it so that the 3 will be divided. The term will be divided by 3. So what could be? If you are taking k is equal to 1, so this is plus 1, sorry, this is plus 1. If k is equal to 1, what will happen? You are getting 3x 27 by taking k is equal to 1. Okay. So then x is equal to 27 divided by 3, it leaves, yeah, 27 is divided by 3, it leaves 9. So therefore, the multiplicative inverse of 3 is 9. Note that that should be, what is that? GCD of 26, GCD of 26 comma a should be the relatively prime, co-prime. Okay, 26 comma a should be the relatively prime. So prime number, you know this. So prime number, anybody? What is the prime number? Yes. Any students who want to interact with me? Do you want to interact? If you like, you can interact, otherwise we shall. Okay, fine. It is prime number. Yes, anyone? What is a prime and co-prime? Anybody want to interact? Yes, it is. How many divisor would be there for the prime number? 1 and the number itself, isn't it? Okay, fine. So relatively prime, co-prime would be the GCD of any number a comma b should be 1, isn't it? The greatest common divisor would be of any two term would be 1. This is also called as relatively prime. Okay, relatively prime. No issue. Okay, fine. So I was also like that when I was doing my undergraduate. Okay, so I was thinking when we think that to study the subject deeply, we may feel that why do we want to study mathematics? Because are we going to do masters? Okay, so like this, I studied my undergraduate. So once going to the masters, then only I realized that to be the good teacher, so we should learn the subjects. Okay, fine. So the co-prime is the greatest common divisor of number should be 1. That is also called as a relatively prime. So you can have the multiplicative inverse that they are co-prime. Okay, fine. Let's find the how we can find it out or read the message. So we need to find the inverse of this 23. This is the number, right? This is the matrix I've taken, my matrix. Okay, to find the inverse of would be, what is that? So the determinant is 17. Determinant would be the 17. We need to find it out the inverse for it. Okay, 1 by 17, 7 minus 3, 15, minus 15, 20. Okay, we need to find it out what would be the multiplicative inverse. So
17 comma 26 are the greatest, they are relatively prime, right? 17 comma 23, the greatest common divisor would be 1. So therefore we can, it is possible. Okay, so you can do this. Similarly, 17x minus 1 mod 26k 26. So 17x 26k plus 1. What would be the k, so that the 17 would be divided? Okay, so when you take k is equal to something 15, okay, so this will be divided. I think you can try. I leave it to you to find it out, the answer for it. I think k is equal to 15. Okay, so you can have x is equal to, if it is 15, then you can have 319 plus 1, and then x is equal to 15 you will be getting. So 15 or 23, sorry, 23. Okay, so 23 would be the multiplicative inverse, and when it is divided by 26, it leaves the remainder 5, 9, 19, 18. 5, 9, 19, 18. So CD, QF. Okay, so this is the message I want to read through this. Okay, 5, 9, 19. The Cth position is 2, Dth position is 3, and Qth position is 16, and Fth position is 5. Okay, when it is multiplied and when it is divided by 26, whatever the remainder leaves. 11th position is L, and 4th position is 14. Similarly, for 21 is V, 4th. So this is the message I was able to read through this inverse. So what you have done, the system of equation, the cipher has taken only the system of equation, Ax is equal to B. This is a plain text. The plain text is transformed through this matrix. Okay, so that you will be getting the ciphertext. Okay, to get back my original message is can be done by A inverse B. Here what you have used, here we have used integer arithmetic modulo n, modular arithmetic concepts are used, modular arithmetic. Now look at this, here linear algebra is there, and then linear solving the system, and then modular arithmetic is number theory. Okay, so linear algebra deals all sort of the transformation, all sort of the geometry. Okay, and whereas the number theory, and that's what we would say. So mathematics is the queen of science. Number theory would be the queen of mathematics. Okay, so these two, linear algebra and number theory, are playing an important role in the mathematics. Okay, we would say this, they are the heart of the mathematics. Fine. Okay, so have we understood this Cipher crypto system? Shall we move on to the RSA crypto system? Another 15 minutes I can spend RSA crypto system. Okay, fine. Okay, thank you. So this RSA crypto system, in which the number theory concepts are very well used. Okay, especially the congruence, modular exponential, the multiplicative inverse, Euler's pi function. Okay, all the things are utilized here. Okay. And of course, as I said, this RSA crypto system was designed in 1977 by the three great mathematicians, Ron Riswest, Abel Shamil, and Leonard Edelman. Okay, so because from their first letter of the name is taken and kept as RSA crypto system. Okay, fine. So to understand this RSA crypto system, we need to know the Euler's pi function. Okay, so this this. The pi n is the number of non-negative integers less than n that are relatively prime. Relatively prime, we have seen this GCD of whatever the number comma n should be 1. Okay. Okay. So pi of n is the non-negative integer that should be less than n and that are relatively prime. Okay. So if n is greater than 1, then pi of n is the number of elements in n. Okay. For instance, pi of 1, it has only one non-negative integer that less than n that are relatively prime to this particular. So now you can take pi of 2. Pi of 2, what is that? This should be less than n. Okay, the number of non-negative integer should be less than n that are relatively prime. So only what is that? 1 should be there. 1 comma 2, the greatest common divisor of GCD of 1 comma 2 is 1. Therefore, only 1 is there. And for pi of 3, look at this. What is that? So GCD of 1 comma 3 is 1. GCD of 1 comma 2, sorry, 2 comma 3 is 1. So therefore 1 and 2, these are the two numbers are there, two non-negative integer that are less than n that are relatively prime to this 3. Similarly, pi of 4, for pi of 4, how many is there? So what is that? GCD of 1 comma 4, yes. GCD of 2 comma 4, is it a relatively prime? What is that? 2 is the common divisor. Therefore, this is not a relatively prime. Okay. So GCD of 1 comma 4 and then GCD of 1 comma 3, 3 comma 4. Yes, it is there. So therefore, this is 2. It has 1 comma 3, and whereas here 1 comma 2. Okay, fine. And then similarly, pi of 5, you can have pi of 5. So how many elements would be there? So 1 comma 5, yes. 2 comma 5, yes. 3 comma 5, they are relatively prime. 4 comma 5, yes. So therefore, the pi of 5 would be 4. Pi of 5 would be the Euler's function, which give the number of non-negative integers that which is the less than n that are relatively prime to this number. Okay, fine. So suppose this is the particular term I'm giving, pi of 59, 51. How one can find it out? The number of integer past non-negative integer less than n that are relatively prime to this. How one can find it out? Okay, so that's what here it is proposed. The result, if p is a prime number, then pi of p would be p minus 1. Okay, so p minus 1 terms are the relatively prime to the p, because p is the, what is it, 1, and the number itself would be the divisor. Okay, 1 and the number itself is the divisor, therefore that is the prime number. Okay, fine. And another result, suppose pi of what is it, 51. So 51 is the prime number, then how many would be there? 51 minus 1. So 50 non-negative integer that are less than n, which are relatively to the prime. Okay, and then suppose p is a prime number, a is a positive integer, then suppose this is what, let me take pi of 32. The pi of 32 can be expressed as pi of 2 power 5, right? 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. Yes, 2 to the power 5. Okay, this is expressed like this, 2 to the power. Then how many you can have? 2 power 5 minus 2 to the power 5 minus 1, 4. So this is, what is that? 32 minus 16. There are 16 numbers are there. 32. This is not a composite number. This is expressed as power to the prime number. Okay, 2 to the power 5. Okay, and this, from this you can deduce p power alpha minus p power alpha minus 1, 16. Okay, fine. This is another result. Suppose a and b are relatively prime. Okay, a and b are relatively, which means the greatest common divisor of a and b will be 1. Okay, and then n into a b, then you can find it out. You can what is it, split them into pi of a into pi of b. Okay. So let me take n is equal to 200. Here let us take a is equal to 25, b is equal to 8. Okay, 25 8s are 200. So what is the GCD of 25 comma 8? 1, right? They are relatively prime. So therefore these such a relatively prime numbers are taken. Okay, multiply them, n is equal to 200, and then we have a results. What is it? So pi of n is 200. This is equal to, what is it? Pi of 25 into pi of 8. Okay. So now what will happen? This you can express as pi of 25 can be expressed as how the previous theorem you can utilize. This can be expressed as pi power pi of 5 square and into pi of, this can be expressed 2 cube. Okay, by utilizing the above theorem, what you can have? 5 square minus 5 into, this is 2 cube minus 2 to the power 2. Okay, simplifying this, what is it? 25 minus 5 here, 8 minus 4. You can have 80 numbers are there that are relatively prime to 200. So this theorem can also be utilized. And finally, this, if n is a positive integer with a prime factorization, okay, then any number you have that is being factorized like this, then pi of n into p1 e power 1, p1 e1 minus 1, p of e power 2 minus p of e2 minus 1. For example, you can take this pi of 2 power 3 and 2 power 4 and 7 squared. This is equal to pi of this 2 cube, pi of 3 power 4, pi of 7 power 2. So what this will happen? This is 2 cube minus 2 square. This is 3 4 minus 3 cube. This is 2. What is it? 7 square minus 7. Okay. So this is also one of the prime factorization results, because all such things are being utilized in the RSA Crypto System. That's what I just want to give a recap on it. Okay, fine. Now let's go into the RSA Crypto System for another 5 minutes. Okay. First, the system goes like this. First, choose any two prime numbers randomly. Choose any two, P and Q, or the two prime numbers that you can choose randomly. And then compute the product of these two prime numbers. N is equal to product of these two prime numbers. Now find out the IS phi function. Phi of n, because P and Q are the prime number, therefore this is factorized as phi of n is would be P minus 1 into Q minus 1. And third step, choose a number between 1 to pi. Okay, choose a number 1 to pi such that that should be the relatively prime number to the pi function. Okay, choose an integer e from 1 to pi such that the greatest common divisor between e and pi should be 1, that they are relatively prime. Okay, now we need to find it out. Look at this. For this e, you need to find it out the multiplicative inverse. Okay, inverse you need to find it out. Multiplicative inverse. Inverse we need to find it out. Okay, that is nothing but d. Okay, d is equal to e inverse mod m. Okay, so I told you how you can find it out the inverse for it, isn't it? Okay, you know this, isn't it? And then after finding this d, such that this de1 mod m, of course, because d is the multiplicative inverse of your e. If it is multiplicative inverse of e, then what will happen? This is congruent 1 mod pi n. Okay. So here, what are the things that you will express privately and publicly? Okay. So the public key would be the number of the product of the two prime numbers. You won't reveal your prime numbers, okay? Because factorizing whatever the number you have, factorizing into the prime number, it's not an easy task, such a difficult task. So whatever we have done, this and all the prime factorization. So prime factorization is not an easy task. That's the reason the prime numbers are highly used in this crypto system. Okay. So n and e are the public key, whereas the private key, your d, the multiplicative inverse, and prime numbers are the private keys, should be kept secretly, should not be revealed. Okay. So here E is the known as the encryption exponent, D is the decryption exponent. Fine. Now encryption is done is m to the power e mod n. Okay. And whereas decryption would be, I mean, yep, this is yours. What is that? Ciphertext. M would be the plain text. Okay. So M would be the plain text, C would be the ciphertext. Ciphertext power D mod n would give the plain text. Now let's see the problem using the RSA Crypto System. So first let us take two prime numbers, 11 and 3. These are the two prime numbers. Compute n, product of these two prime numbers, 33. Okay, and third one, find the Euler's phi function. Okay, p minus 1 is 11 minus 1 is 10, and 3 minus 1, 2, 10 2s are 20. You have done the pi of n. And choose an integer from 1 to pi of n such that the e and pi of n should be the relatively prime. Okay, so we have chosen 3 and 20, they are relatively prime. Yes, greatest common divisor is 1. Now we need to find it out, the d. D is the multiplicative inverse of your e. So what will happen? D is equal to d congruent 3 inverse of mod n. So this we know this. Let us take 3 inverse is taken as x. So 3 inverse is taken as x. Okay. So yeah, 3 inverse. So 3 into x, 1 mod 20. What will happen? 20 under mod 20, right? Because this is n, pi of n. Okay. Okay. And then what is it? 3x minus 1 is equal to 20k. Then when k is equal to, yeah, 3x is equal to 20k plus 1. What is that k? K could be 1, so that this will be divided by 3. So x is equal to 7. So therefore d would be 7. Okay, you found the multiplicative inverse. And after this, the public key would be n is 33, the e is taken as 3. And the private key is the multiplicative inverse of e is 7, and then p is 10, and q is 2. What is it? 11 3. 11.3. Okay, 11.3. Fine. Now the encryption is done through this. C, M, D is, sorry, E is 3, mod 33. M would be the plain text. Okay. And the decryption can be done C to the power 7. 7 would be the inverse of 3, multiplicative inverse of 3, mod 33. N is 33. Fine. Suppose our friend Reshma wants to send this message to her friend Fatima, email. She wants to send this message. The ETH position is 5, M position is 13, A position is 1, okay, I position is 9, L position is 19. Okay. So take, what is it? This is the M is taken as the plain text. 5 to the power 3, because this is the encryption, right? 5 to the power 3 mod 33. 5 to the power 125. When it's divided by 33, it leaves the remainder 26. Okay. 26 is Z. Okay. Similarly, the second term, 13 cube, multiply them, divided by 33, it leaves remainder. So finally, the email is encrypted ZSACL. And how are you going to get back this message? So what is a M congruent decryption? How the decryption is possible? What is that? M congruent C to the power of mod 33. So C, whatever the Z position is 26, S position, A position, that you will be putting here, and to the power 7, when they are divided by 33, whatever the remainder leaves, which give the decryption, the original message you get back. So in this RSA Crypto System, what are the things that are being involved? You can see that. Okay. So Euler's pi function, the modular arithmetic, and prime factorization, all the things are being involved. Okay. So the factorizing prime number is not an easy into prime number is not an easy task, and then finding the multiplicative inverse of the number is not easy. Therefore, it would take a lot of time for the person to break, the third person to break it. Within that person, second person will receive the message from you, and you will go ahead what the task that you are given. So after completing the work, if the person breaks the message, what is the use of it? So therefore, here the number theory concepts and Euler's pi function, prime factorization are all utilized. Therefore, RSA Crypto System is strong enough. Now, a lot of research is going on the number theory for this cryptography. Okay, fine. So it has various applications, for your linear system of linear equation, the graph theory, game theory, and neural net data science and neural network. It is there. And number theory, as far as number theory concerned, to send the things secretly, our ATM, whatever the OTP pin that we are getting, right? It is done through your number theory concepts. Okay, fine. And finally, I would like to give this to all of you, because since it is a number theory, since my talk was a number theory, I want to tell about John Andrew Wells. Okay, John Andrew Wells. So he's the person who was the recipient of Abel's Award for the year 2016. Okay, 2016, he was the Abel's Award. Okay, so what contribution he has given? Okay, so in 350 years ago, Fermat's proposed this x power n y plus y power n is equal to z power n as no solution when n greater than 2. Okay, when n greater than 2, this x power n plus y power n, z power n is no solution, isn't it? So x plus y is equal to z. So what is that? 1, 3 is 4. So we know this. So when you increase the power, x square plus y square plus z square, and it has the solution. Can you give me the possible solution? What is that? 3 square, and then 4 square, 5 square. It is there. And if you are increasing x cube plus y cube, z cube, no solution, right? It is, we cannot find. So Fermat has posted only this conjecture. Conjecture means it has not proved yet. The statement which has not been proved yet. That's what the conjecture is. In mathematics, whatever you say, you should give the proof, you should give the evidence. Okay. So he has only posted this, and he tried for n is equal to 4. He gave only for n is equal to 4, and then he demised. And after him, so many mathematicians, Euler, Commerce, Lagrange, so many mathematicians had tried, and they were able to give only for n is equal to 16 some discrete case. Okay, nobody was not able to give the generalized proof. This John Andrew Wiles has gave a proof. He gave the proof, and he was given this Abels Award. Okay, during the time of receiving this Abels Award, so many the interviewer and the people from the magazine who asked him, how did you get this? Here, so many great mathematicians were tried upon, but nobody was able to succeed. And how you were able to succeed? Such a question posed at him. He said, I was 10 years old in the library. I was reading the books in the library. I would read this this x power n plus y power n is equal to z power n is no solution when greater than 2. At the age of 10 itself, I was able to understand this. Why I cannot give the proof for it? And he was always thinking about this equation when he came to college and after his doctorate, and he was sit along with his Rsa scholars, and he gave the proof. Okay. So in the year 1996, 92, he gave the proof, but still they found the fault in it. And later in 1996, I think 1996, he gave the revised proof, and the proof was accepted by everybody. And after 20 years, in 2016, he gave this award. Okay, and he was telling to all the mathematics professors and mathematics teacher, mathematics students that so whenever you look at the equation, you should look how you will look at the flower, how you will look at the jasmine, how you look at the rose. Like this, you will look at it, and behind the equation, there are a lot of beauty things are there. Once if you are able to view that perspective, you can really enjoy and really taste the mathematics, taste the essence of mathematics. I hope that so we are all blessed to study mathematics. Not now, after certain stage, you will realize it. Mathematics subjects, how beautiful it is, that you really realize. Okay, at some particular time, the time will come. And of course, finally, I want to tell this. Nowadays, the trend is data science, okay, and machine learning. I request all of you, please learn any programming language, Python, and be thorough with your linear algebra and statistics, because the data scientists are highly required now. Okay, so after your masters, if you are good at this, and you are definitely being given a very good salary. Okay, so please train yourself with this perspective. So with this, let me wind up. I think I have taken some 5 minutes extra. I'm sorry for it, because with that, let me wind up. Linear algebra is the mathematics of data. Matrices and vectors are the language of the data. And of course, your number theory is the queen of mathematics. Okay, so these are the two subjects are really interested thing. So please, you can also have a glimpse. Master students, you would have understood much better than the undergraduate student. For undergraduate student, don't worry if you are not able to understand. And whatever you understand with this, you can take it forward when you learn masters. So with this, you can generate many things. So all the very best for your future. And I really thank the management of this particular college for providing this wonderful opportunity. And my special word of thanks, my friend Professor Krishna Kumari, for bringing me here to interact with my students. Thank you, Mahalashmi Women's College of Arts and Science. So this is my reference for my talk. And thank you very much. If you have any questions, you can provide. Yes, anything. If you have any questions, you can ask. I think you're all very hungry. I know that. And think it over. I have a class from 9:52 till 12:25, and then continuously I'm taking. So Monday I'm fully engaged, and after 3:30 I also have a class. So once you start to learn mathematics, I think that you may feel hungry. Okay, am I right? Any students? Deepika?
I request all the participants to ask your queries in the chat box. Now, I would like to call upon Mrs. M. Krishna Kumari ma'am, Assistant Professor, PG Department of Mathematics, to share a few words regarding today's session.
Good afternoon, sir. Sir, I'm extremely impressed with your talk on Hill Cipher and RSA Crypto System. It's really useful for the young generation, those who are going to live for long years in this digital world. I'm highly grateful for your presence in this great occasion on 46th day of MAHA webinar marathon. Thank you, sir. Thank you so much, sir.
Hello, sir. Sir, the session was really very excellent, sir. It's a new topic for us. We have learned so many things today. We didn't expect that it's like a usual webinar, but really, I'm telling you, we have understood very clearly whatever you told in the presentation. And one thing I just want to highlight, you have ended the session very nice, sir. Like we have to see the class, how we are, the approach, how we are going to see. The same thing we have to see our subject also. Excellent, sir. Thank you for coming, sir.
Shakti Devi.
Yes, ma'am.
Proceed, ma'am.
I call upon G. Bhavani of 2nd BSc Mathematics to deliver a vote of thanks.
Good afternoon, everyone. I'm Chief of 2nd BSc Mathematics. I would like to present vote of thanks. I would like to express my gratitude to all esteemed delegates of the webinar for present and contribution to make this webinar take care. I extend my gratitude of our honorable guest, Dr.A.FELIX, Assistant Professor, Department of Mathematics, for spending a valuable time with us from his busy schedule. Today's webinar is full of knowledge and useful to all of us. Really have attracted all our attention by your wonderful session. Thank you so much, sir. I may also like to express our sincere thanks to Chairman, Thiru S. Badam, sir, Managing Director, Thiru S.K. Thirukumaran, sir, Thiru S.K. Senthilkumar, sir, for organizing the webinar. Thank you, sir. And I also wish to express my gratitude to our beloved principal, Dr. R. Kovinita, and Dr. Ramasamy, sir, and Dr. Indumathi, ma'am, for your support and kindness. Thank you, ma'am. I thank you all the different HODs, faculties, and participants for the kind cooperation. Finally, I extend thanks to organizing committee and technical team. So again, thank you all.
Thank you, Bhavani. I ask the participants to kindly fill the feedback form in the chat box. I thank everyone for the kind cooperation. Thank you all.
Thank you. Nicely you've organized. The MC was good, my dear student. Good. Thank you,
Thank
ma'am.
you, sir.
Yeah. Shall I leave, ma'am?
Yes, sir. Yes, sir.
Yes,
Thank you,
yes.
sir.
Thank you, ma'am.
Thank you so much, sir.
Thank you, ma'am.